Welcome to Gilat Research Center, which is the southern campus of Vulcani Institute. Today, we became a group of scientists working in the subject of plant nutrition. A major part of this activity is results of the contribution with ICL. A major part of our activity concentrated on nutrition of fruit trees based on container experiment and field trials. With our ability here in Gilat to make all this measurement, today we can come with information how to supply the nutrients to fruit trees.
So what we got here is a big experiment in which we check what is the effect of nitrogen, potassium and phosphorus on the tree growth, and what is the optimal fertilization that we need to give in order to get maximal yield. It's not only how much fertilization to give along the year, it's also how to spread it along the year. Should we give all the nitrogen at the beginning of the summer, during the flowering stage, or during the fruit development? Should we give the potassium at the beginning, or at the end of the year?
So we are standing in front of a new experiment that we just started in order to evaluate the response of table grapes to variable level of potassium, phosphorus and nitrogen. The final objective of this experiment is to provide the farmer with recommendation of the right amount of fertilizer they need to provide their crop. In this experiment we will follow the vegetative growth, the productivity and the grape quality.
One of the main problems in growing vegetables under protective environment is the high temperature inside the greenhouses and net houses. This temperature causing heat damages, for example, in the fruit or poor fruit set. One of the things that we are trying to understand, how can we assist the crop to cope with these high temperature stresses or damages. For example, in peppers, heat damages on the fruit causing a reduction in the fruit quality and reducing the shelf life of the fruit. We found that by applying manganese and zinc, we can modify it, we can improve how the crop is coping with this problem.
So we had a very interesting project in almond where we saw the effects of nitrogen on the fruit. And on top of all the other effects that tree physiologists and other researchers saw, we saw huge effects on the health contribution of the almonds, on the phytochemical composition of the seeds themselves.
In Israel, we're water scarce. We don't have enough water to supply for agriculture. We didn't historically have enough water to supply for our general population. And therefore, the success of agriculture is very centrally concentrated on issues of water and issue of irrigation. That starts with water supply and water distribution. And the uniqueness here in Israel is the amount and the extent of the use of alternative or non-conventional sources of water for irrigation. That includes brackish groundwater, salty water coming from wells that we're pumping and using. And it's even more importantly includes recycled wastewater. We're going to see that a lot of our projects and our issues of fertilization and mineral nutrition are connected to water quality. The other thing, because of the water scarcity, is the continuous attempts to be more and more efficient with the water that we're using.
We are testing whether we can increase the productivity by supplying the tree with optimal nitrogen, phosphorus, potassium, micronutrients levels. So we're testing a wide array of concentrations in these control conditions and see what's the response of the trees. I must say we were very surprised to see that different trees act in different way. The results we found in olives or pomegranates are very much different than how the avocado responds to fertilization. One of the benefits of this very unique system is that it is a closed system, so we can do mass balance of water, of nutrients, The avocado tree acquires substantial amount of nitrogen during the winter, which was very surprising to me because soil temperatures are low and we expect to have very low root activity. And this novel finding is now being tested outside in field conditions.
We are assessing different rootstock for avocado cultivation under salinity condition. The water quality in Israel is relatively low. We are using recycled wastewater which contain relatively high level of sodium and chlorine. Here we assess different rootstock. We have around 20 different rootstock and we select the best rootstock that will be suitable for the new plantation in this area. The findings so far have shown us that there are some that maintain high productivity with high resistance to salinity, and nursery and later on also the growers start to use those rootstock in their new plantations.
Hohova is a very interesting crop here in the Negev. It's a shrub, and the wax that is extracted very valuable in cosmetics. And Israel is one of the main centers of jojoba worldwide. We have about 40% of the global production of jojoba.
In this experiment we are assessing the nitrogen requirement of this crop. We have 5 different levels of nitrogen, and we can learn from the result till now that the requirement of nitrogen of this crop are relatively modest.
In jojoba, we saw great effects of water management on the wax quality. We saw effects on the fatty acid and fatty alcohol composition of the wax. And we're still studying the effects of plant nutrition on the same wax.